I'm looking at a dataset with 5 different characteristics and 100 individual data points. Think of it like 100 people, each described by 5 different measurements, like height, weight, age, etc. This is the core of the problem. I need to calculate how the 5 features relate to each other. Whether, for example, height and weight tend to increase together. The standard method to do this uses the average values of each feature. The key question is whether my dataset has outliers, data points that are unusually far from the others. Outliers can severely distort the average value, and thereby, the calculated relationships between features. Yes, I'll assume outliers exist in this dataset to make the problem more challenging and realistic, and explore how that influences the covariance calculation. This is the overall topic. I'm investigating how well a common method for calculating relationships between features, empirical covariance, performs when outliers are present in the data. I'm presented with a multiple-choice question to test my understanding of how outliers affect empirical covariance calculations. I'm being asked to identify which statements accurately describe how empirical covariance handles outliers. This statement claims that the method used is naturally resistant to outliers. I'll need to determine if that is true. Let's imagine for a second that there were no outliers. Then, the calculated relationships between the features would be reliable. This is the ideal scenario that we compare the outlier scenario to. We're diving into how well scikit-learn's "empirical covariance" handles outliers in calculating covariance matrices. Think of a covariance matrix as a measure of how much different features in your data change together. Outliers, those unusual data points, can really mess up this calculation. This row represents the measurements for the first sample across all 5 features in my dataset. Let's imagine each feature is like a different characteristic measured on a person. Sample 1 might have the person's height, weight, age, blood pressure, and income. This is a similar line as sample 1 but for the second person. The values indicate the measurements taken on those 5 features. So, we are capturing 5 measurements for this person. This ellipsis indicates that there are more samples, observations, like sample 1 and sample 2. I have 100 such samples in my dataset. The last sample in my dataset. Similar to the previous samples, this row represents the measurements of 5 features for the 100th person or observation in my dataset. Each of the rows from 11 to 14 represents a distinct sample from my dataset. I'm talking about how scikit-learn's EmpiricalCovariance handles data, specifically whether it's good at dealing with unusual data points, or outliers. It's a crucial concept in statistics because outliers can really mess up your analysis. We're working with a specific dataset. It has 5 different characteristics, features, for each of the 100 individual pieces of data, samples. Think of it like having 5 measurements on each of 100 people, like height, weight, age, blood pressure, and so on. This is important context for understanding how the covariance is calculated and how it will perform with a given sample size. We're going to examine several statements about how well EmpiricalCovariance handles outliers and pick the ones that are true. We're really testing your understanding of how EmpiricalCovariance works and its limitations. This statement claims that EmpiricalCovariance is naturally good at ignoring outliers. I'll tell you that's incorrect, because it's not designed to be robust to outliers. The standard calculation is sensitive to them. This statement correctly says that EmpiricalCovariance is affected by outliers. Outliers can significantly change the results it produces because the way it calculates covariance is easily swayed by extreme values. This suggests that having more data points will make EmpiricalCovariance less sensitive to outliers. It's partially true, because a larger sample can sometimes lessen their impact. But having more data doesn't completely solve the problem. Outliers will still distort the results, just perhaps a little less. This is the correct option. It says that before using EmpiricalCovariance, we should clean up our data using techniques like removing outliers or capping their values, Winsorizing. Doing this makes the covariance estimate much more reliable. I'm looking at how scikit-learn's empirical covariance handles outliers in estimating covariance matrices. It's all about understanding how much those unusual data points affect the results. This is a multiple-choice question testing your knowledge of how outliers impact empirical covariance, a method for estimating the covariance matrix in a dataset. This sets up the scenario. I have data, I'm using a specific tool, empirical covariance, and I need to decide how sensitive this tool is to outliers. This statement is incorrect because EmpiricalCovariance uses the standard method of calculating covariance and isn't designed to handle outliers automatically. It's not a robust estimator. This is correct, because the standard way of calculating covariance is very sensitive to outliers. They strongly influence the results, leading to inaccurate estimates. While more samples generally improve things, it doesn't solve the problem. Outliers will still mess things up, though their relative influence might decrease slightly. This is partially true but not entirely accurate. This is correct. I can make EmpiricalCovariance more reliable by getting rid of or adjusting outliers before I run the calculation. This makes the whole thing more robust. I'm working with a dataset that has 5 different characteristics for each of the 100 things I'm measuring. This section introduces the core topic. We're exploring how scikit-learn's empirical covariance handles outliers, data points that are significantly different from the rest of the data. I'll focus on whether this method is robust, unaffected by such outliers. This is the core question of the quiz, focusing on how the method deals with outlying data points. I'll need to carefully consider the impact of outliers on the covariance calculation that this method performs. This statement says that empirical covariance is strongly affected by outliers. I need to consider if this is true. It's an important consideration because the presence of outliers can significantly distort the results of a covariance calculation. Outliers can inflate the calculated covariance values, leading to inaccurate or misleading conclusions. This statement suggests ways to improve how empirical covariance handles outliers. Data pre-processing refers to steps done before the analysis. I'll have to evaluate whether outlier removal or winsorizing, limiting extreme values, helps make the covariance calculation more reliable. Pre-processing steps like removing outliers or adjusting extreme values, or winsorizing, often significantly improve the reliability of the results. I'll evaluate whether simply having more data points reduces the effect of outliers on the covariance calculations performed by empirical covariance. The more data you have, the less influential individual outliers might be. However, it doesn't completely remove their effects. I'll analyze if the empirical covariance method is naturally resistant to the influence of outliers. This is a fundamental property of the method that I need to understand. This gives the context of the data that I am working with. It has 5 different characteristics, features, and 100 individual data points, samples. It's important to know this to assess the effect of outliers within the context of this specific dataset. This is the specific scikit-learn function I am using to estimate the covariance matrix. This is the core statistical method being evaluated. Empirical covariance is a standard method for estimating covariance, but it has limitations that I need to consider, particularly its sensitivity to outliers. This is what the empirical covariance function computes. It's a square matrix showing the relationships between the different features in the data. The goal of the quiz is to evaluate how accurately this method calculates the covariance, especially in cases of outliers. The covariance matrix is a key concept in statistics and provides crucial insights into the relationships between variables. Understanding how these relationships are affected by outliers is important. This section's title clearly tells us that we're focusing on how scikit-learn's empirical covariance handles outliers in datasets. I'll be explaining how this function works, and what its limitations are when it comes to noisy data. It sets the stage for the entire quiz. This question is the core of the quiz. We're asked to evaluate 4 different statements about how empirical covariance behaves in the presence of outliers, data points that are unusually far from other data points. I need to carefully consider each option's validity. Let's dive in. This gives us the context of the data that we're working with. We have a dataset consisting of 100 data points, each described by 5 different characteristics or features. This is important information because the size of a dataset can influence how sensitive a method is to outliers. The more samples the better, but not perfectly. This statement is incorrect. Empirical covariance uses a standard method for calculating covariance. This method is very sensitive to outliers because those extreme values heavily influence the average calculation, which is crucial in determining covariance. I need to remember that it is not robust to outliers. This statement is correct. Outliers can drastically skew the calculations used by empirical covariance because the formula is directly influenced by the sample means and variances, which are strongly affected by extreme values. Therefore, the resulting covariance estimate will be unreliable. This is partially true, but misleading. While it's true that more samples generally give you a better estimate, this doesn't make it immune to the problems caused by outliers. Outliers will still skew the results, although their relative impact might be slightly smaller with more samples. I need to be careful with such statements. This statement is correct. Pre-processing steps such as removing outliers or winsorizing, limiting extreme values, are effective strategies to mitigate the damaging effects of outliers on covariance estimations. These methods effectively prepare the data for a more accurate covariance estimation.